Hey, hello everybody. Welcome back to the stream. So we're continuing work on our C interpreter today. Last week we added function parameters and arguments to function calls. So we were able to rewrite our recursive fib function to actually use parameters instead of having to go through global variables, which made it a bit faster. So we can write a very simple program that computes and prints Fibonacci numbers. But note that to do any sort of branching decision, we are currently relying on the ternary operator because we haven't implemented things like if yet. So that's the plan for today. We're going to implement if. Then we are also going to implement while, so we can write a version of Fibonacci that runs iteratively, which is going to run a lot faster than the recursive version. So let's get started. We want to add a new kind of statement. So we need to add a new kind of AST node. And the statement that we're going to add is an if statement. So an if statement, if we look at the standard, it consists of an expression, then something called a secondary block, and then an optional else statement at the end. Now, what's a secondary block? A secondary block is just a statement. It's some technical term due to the way scoping works. But we're not worrying about scoping just yet. So an if statement is an expression, a block, and an optional else block. So when we go to statement, so we want an if statement. Let's add it right after the return statement. An if statement. Yeah, we know what an if statement is. So this is an if statement. An if statement has kind if statement. It has two constructors, the condition, and then the then block. Children after condition then. And the other version also has an else block. So condition then else. Then we can get the condition. We can get the then statement after the condition. And we can get the else block after the then statement. But we might not have an else statement. So how do I check that? Child after then null pointer. Okay, so that should be our if statement. We've added a new node, so we need to adjust this here. So we now have an if statement. This should compile. Let's use the if statement here. So if n is equal to 2, then we want to return n, else we want to return that. Okay. So this won't compile because it doesn't know about if. So let's add that to the compiler. So we have a new kind of keyword. So in fact, we got if. And we've got else. And then return statement. We also want to add an if statement. Its position is identified by the if keyword. Then we want parenthesized expression. So if expression and then a block, or rather a statement. Recurse statement, and then we might have an else block. So if we have an else block, then we want to pass another statement. So the values, then we simply construct our if statement. Why are you? I don't think this error means anything. And then a statement, we also have if statement. Oh, struct, not static. Okay, so now we're parsing it, and we've got an if statement, which has an expression with a return statement, and then another return statement. So the parsing looks good. We're just not handling it in CodeGen yet. So let's handle it in CodeGen. When we want to visit an if statement, where do we visit statements? I believe it was called past it. We're visiting statements right here. So we want to manually visit them. We need to visit the children, so we pass in a child visitor. And then we've got our if statement. Okay, so the first thing we need to do is evaluate the condition. So we do that by visiting it. Now 0 or 1 is on top of the stack. And then we again need to create separate basic blocks, essentially the same way we already handled the, where is it, the conditional expression. So we evaluate the condition, and then we do a branch to potentially different blocks. So we can essentially copy the entire structure like so, because it's like there is no difference between an if statement and an expression, ternary expression in that sense. So however, we can simplify things because we know that statements cannot return value. So after a statement has finished executing, the stack is empty. So we don't need to worry about the stack size. So we know that when we enter the true block, we don't have anything. And when we enter the false block, we don't have anything. And when we go to the end block, we also don't have anything. So branch to one of the basic blocks. Okay, and so this instruction will go to either jump to block of true or block of false, depending on the value on top of the stack. And if we know that, for example, if we have an if true, we statically know which block to jump. And then we don't need to generate code for the block that isn't taken. So if that is the case, it will return a compile time noun target. And otherwise it will return null pointer. So if we only need to evaluate the if true case if we know that the compile time noun target isn't the false block. If we know that we're always jumping to the false block, there's no need to evaluate the true if statement. So evaluate the then statement. So we start building the block if true, and then we visit the then statement. And then we jump to block if end, and likewise evaluate the else statement. Else, then jump to the end, and then we continue in the new block. Okay, and I believe this should now work. It does. So essentially generating exactly the same code, just now using an if statement instead of the ternary. So this is the then branch, and then this is the else. And like debug info works nicely, so that's good. Now, of course, if we were to start writing a test for it, let's say if I don't have two, so if one assert 1, else clog assert 0. So that's a very basic test. Let's do it a bit smarter. So let's say int I, and this sets I to 1, and this sets I to 2, and we want to assert that I is 1. Okay. I equals to let's assign it to, okay. So let's assign I again to 0 and say that if you want to take the branch, then we assign I to 1. And this should now be 1. Right, and this only happens to work accidentally. So let's add write separate functions. Because I was trying to trigger a crash, but it constant folded away, so it didn't crash. Let's write a separate function. So let's say if else, I can do it. Okay. Condition. So if condition return 1, else return 2. So then I can say clf assert if with else 0 is equal to 2, and if with else 1 is equal to 1. Let's write the test like so, that's a good idea. If without else, and condition, if condition return 1, return 2. Okay, and now we should crash. Yeah, now we're crashing. And the reason we're crashing is because we don't handle the case that we don't have an if statement. An else, because this can be optional. So we need to handle that. And let's just say that if not statement has else. So we only do that if we have an else, and otherwise we immediately jump to the next block. But we're still crashing. That's interesting. That's very interesting. Why are we still crashing? Let's debug this one. Tests integration if. Oh, we're somewhere in the debug info. Oh, that's interesting. So we're crashing. So we're generating the issue, we're crashing, we're generating debug info by iterating. The statements aren't. Let me do that. And now we're getting a segfault, so that's something different. We're in some sort of visit when we want to visit the condition. Why are we segfaulting? That is very interesting. Let me enable sanitizers, so we might figure out what's going on here. Okay, so we are getting a Stack Overflow. Wait, why are we getting a Stack Overflow? Okay, because that is very interesting. So what happens if I do this? So we're getting a Stack Overflow because somewhere in the past there's some sort of loop. Let me see what the function says. So we've got a function if without else. It consists of a block statement with a condition and then statement and then nothing else. So the tree looks correct. Yeah. So the code gen obviously is now broken because we're not generating code for the else case. But in the case of if without else, we are doing the condition here, then we're pushing 0 and returning, otherwise we're pushing 2 and returning. So that is correct. So apparently this check right here is broken. Can I get my language server back, please? So if statements, this is probably because child after returns, right. So we're checking whether we have an else block by asking for the child after the then node. And if that is non-null, then we're having an else block. However, there is a bug in this child after function. So for the last child, it does not return null pointer. It returns this. So the last child has a pointer back to the parent and not a null pointer, which isn't the correct semantics. It should return null instead of this. Okay, now we're getting the memory leak. So when we visit the if statement, we are actually evaluating it again correctly and we're not crashing, and the test pass. Okay, so we only evaluate the if statement when we actually have an else block now and without crashing, and I need to fix that function of Cramer. Okay, let me take a look at the bytecode for if with else, or rather if without else. So okay, and this is what I was worried about. So when we don't have an else statement, we're branching to the block if the condition was false. Then we're doing nothing and immediately jumping to the next block. But there is no extra jump condition. So we're branching, if it's equal, we're branching directly to the false block. So there is no nested jumps. I was worried about that, but this isn't something that we have to worry about. Okay, so the final thing that we need to test for an if statement for now is if with else if. And there is actually no such thing as else if in the C language, because this is just the same. Let me write that out. So this is just the same as this. So an else if is just an else whose statement is another if statement. So there is no separate language feature for else if. It should, in principle, just fall out nicely out of the semantic. So let's test this. If else if 0 should be 0, 1 should be 1, 2 should be 2, and 3 should be 2. And that seemed to work out. Okay, there is this thing as dangling else, which is, yeah, but we should be handling it correctly. So if we run the passkey for the if else if, we can see we have an if statement whose else statement is another if statement, and that is an else if, because it's just, right, we can just forward it like so, and this makes it obvious. But else if isn't actually a language feature. So we've implemented if statements. Let me also check whether this fixed the other assertion that we in the bug that we had earlier. So when we generate the debug location, can I use the anchor again? We can. Okay, good. So reminder to myself, fix the child after function in Dryad of Camera. So add if statements. Okay, next up we want to do while statements. So loops. While is even simpler than if. It's essentially just like an expression and then another secondary block, which is just a statement for now. So while statement. While statement. looks the same as the if statement, so let's copy that. A while statement, while statement, while statement, body. So this is a while statement. We don't have an else for a while statement, and instead of when, let's call it body. Did I copy paste? Oh, copy pasted it twice. Okay. Copy pasted it a bunch of times. Okay. So added a new node, need to update this enum. While statement, while statement. And let's try and use this. Let's see, test.c. So we want to do an iterative version of Fibonacci. So the idea is as follows. We have two variables a and b. A is equal to 1 and b is equal to 1. And while n is bigger than 0, we're doing we're creating a temporary. We're assigning the temporary to be a plus b, and then a becomes b, and b becomes a, and b becomes the temporary, and then we're returning b, maybe. Let's fix the bug later, but something like that. Note that we don't have initializers at the moment, so I have to declare the variable and then assign it, because we don't have variable initializers. Helps if I run the correct code again. Test.c. So now we're getting a parse error and then a bunch of crashes, because we're not handling parse errors gracefully. Rather, we should abort compilation earlier than we're doing, so we're getting a bunch of errors, but that's something we'll fix later. Okay, so let's parse while statements instead. Let me get a statement. Okay, so looks syntactically the same. We just don't need to bother with the else part. The introduction keyword is while, and then we're constructing a while statement, and then I of course also need to add a while keyword. While. Okay. Yep, we're not using that yet. I noticed that as well. So return statement, if statement, or while statement. Okay. The tree looks good. We've got a while statement with a condition, and whose body is a block statement. So that's all nice. We just need to edit the code gen. So when we're handling the while statement, similar thing. So let's we want to handle a while statement. Now, the first thing we're doing is so sort of the canonical way to represent loops in basic block is we've got something called a loop header. Evaluate condition, branch to loop end or loop body based on condition. So we've got a loop body, which evaluate body, jump to loop header, loop end, continue with the rest of the program. So that way the condition gets repeatedly evaluated every time instead of just once with a loop statement. So we need 3 new basic blocks, block loop header. So we declare a new block, doesn't take any inputs because they're all statements. We've got a body, and we've got an end. Then we're immediately jumping to the loop header. Because this is a while statement, it always needs to evaluate the expression first. So as a jump to the loop header. Then we start building the loop header. Inside, we evaluate the condition. Evaluate condition in loop header and branch. So visitor statement condition. And then we do a branch on if the condition is true, we want to evaluate the loop. So we go to the loop body. If the condition is false, we want to terminate the loop. So we jump to the end of the loop. Evaluate body. So, and we only want to evaluate the body if we didn't decide on constant folding that we're having a while false loop. Then we never want to evaluate the body. So if the constant target is the other way around, block loop end, then we never want to evaluate the body because it will never be executed. We start building the body otherwise, build block loop body, evaluate the body, and then we unconditionally jump back to the loop header to try again. Block loop header. Now, if we're having an infinite loop, the rest of the code is unreachable, so we don't need to evaluate it. Continue on with the rest. Yeah, let's not worry about constant following in that case. So let's start building the block loop end. And then the rest of the program will just add part to the end block. And that should work now. I've got an integer overflow. Right, I know where I got an integer overflow. But if we can look at the fib code, so we're allocating a bunch of local variables. This stores the parameter. Then we are in line 11. We are setting a to 1, which does it in a weird way. Why are you? Okay, not my problem right now. So we're setting a to 1. Then here we're setting b to 1. So this is an address in hex, so address 16, 8 bytes integers makes sense. We are also setting that to 1. Then this line 14, this is the loop header. So we're loading the argument, we are comparing it against 0, and if it's less than, then we jump to 20. 20 is line 22, so this is the loop end block. So if n is less than 0, less than or equal to 0, so branch if less than or equal, then we jump to the loop end. Otherwise we fall through to 17.9, which is this line, and these all make up the body of the loop. At the very end we've added a jump back to 0d, which is the beginning of our loop header. Now of course, my language server tells debug already we need to do that. And okay, this is some sort of, this is not the correct value, so I probably need to return a instead. So let's say, what is the 0th Fibonacci number? Let me switch away from the leak sanitizers. We should probably fix the memory leaks at some point, but priorities. So fib0 is 1, fib1 is 2, yeah. So we have to return a instead. So first Fibonacci number is 1, second one should be 2, second one is 2, third one should be 3, with 3, and then we should have 5, 5, and then the 35th one is not that one. So the third Fibonacci number is 3, the fourth one is 5. Right, that should be correct, I believe. But that's not the correct value. There is... Let me Google how to write the function correctly. Iterative Fibonacci. Not that that is important, but I want to see whether it's a bug in this code or in my compiler, which is, I guess, kind of important to know. Stack Overflow, an iterative algorithm for Fibonacci numbers. 0, 1. Oh, should start with 0, 1. And that's the 35th one. Okay. So we've implemented while loops. That's great. Let me... And what other should we do that? Let's see how the performance now compiles compares with when we want to see that versus Clang. So how fast are we? Now that we are no longer using recursion but iteration. Yeah, the everything that uses Lexi always takes a while to compile. So Zilov takes 4.5 milliseconds and Clang takes 60 milliseconds. So now we are comfortably faster because it's a lot less work to generate bytecode and interpret bytecode than to actually compile machine code. Only when the machine code takes a very long time to execute, then compiled code gets faster. So now we are way faster than Clang to compute because, right, it takes almost no time to actually compute this couple loop interpretations, and the overhead of compilation is just a lot more. So we are now a lot faster, which is nice to see. Let's we've got an integer overflow, which is why we're terminating. Right, we've got an integer overflow, which would be UB on Clang, but we are checking all UB. I don't know what is the actual 64-bit integer limit. So 60 works. What about 80? 80 works. 90. 90 works. 95. 95 is an overflow. 93. 93 is an overflow. 92. 92 is an overflow. 91. Okay, 91. And let's see how we compare computing the 91's Fibonacci number. Yeah, barely any time. Whereas Clang takes a couple of milliseconds to compile that. So that's cool. Are there any hotspots? No. The main hotspot it didn't run for so little time, it barely got all these samples and the startup time of the executable. This is the only function that it actually profiled in our code, and this is the one that creates new S nodes. So, right, this creates new nodes. So it went too little to get any meaningful profiling information. So that's really cool. We've implemented loops, which means we can now write really efficient, quick to execute code. While loops. Okay. C has two kinds of while loops, and there's also the do while loop, and this behaves exactly the same. It just first always does one loop iteration before doing a while loop. So we can imagine that a do while loop. So while expression body, and then a do while loop body while expression. This can be transformed into body while expression body. This is exactly the same code. So when we want to implement that, this can be easily done by just adding some sort of kind. So let's say enum loop kind loop while loop do while kind, and then I can do, I did that here. Loop kind. Let's rename the loop kind t 316. We store that in some spare bits in the base class. And loop kind, that loop kind impl to kinds. Okay, and then we need to update the parser. While statement. So we now have a while statement, which I guess we do. So we've got the while prefix. Let me. I need to get the kind value in there nicely, which I can just do, I guess, with by binding this one using. Let me see. So the position while statement loop while like so. Does that compile? Nope. Ah, right. This doesn't like it because we are dealing with parse state. So let's not do it. Let's just do a hack and say while prefix. So this is a rule that does parses our keyword, and then it produces value a constant while statement. So the issue is we want to get past the kind to the constructor, but I was too lazy to add the lambda. So instead I'm writing a custom production. It does it for me while prefix. So now this will construct the correct kind of loop. So this compiles, and we can pass a do while loop, a do while statement, let's just call it prefix. And in this case, the prefix is the keyword do. We're getting the kind do while, and then we want the prefix. And statement copy while parenthesized expression. And I've just realized that there's a lot nicer way to distinguish between them in the constructor because we need to do. In the case of a while statement, we got the body first, then the condition. So I could have just used that to determine whether or not this is a while statement or a do while statement. But it's nicer that way. So kind, condition, body. We've got a new keyword, do. All right, we're not using the do while statement. While statement, and I guess while we're at it, we also need to print whether or not a particular loop is a while loop or do while loop. So when we print statements, we need to const while statement switch statement loop kind while statement loop while Then we want to print while. Otherwise, we want to print do while, I guess. Like so, or something. I don't know. Need a comma here. Okay. So now we can correctly pass while statements and do while statements. I guess let's just, we don't need fib anymore. Let's keep the function because it's so nice. So let's just say do while n equals 0, I guess. Zero print n minus gleich 1, n equals 10. Forgot to pass a semicolon. So do while statement, we want a semicolon here. So in our main function, we've got a do while statement. And so when we print it, we get 10, 9, 1, and so on. But of course, we're not actually doing anything in CodeGen. If I start with -1, we will not print anything because we are generating the same code for while and do while. So we have to fix that. And this is quite a simple fix. So when we do a while statement, normal while, do while, it has the exact same. So this is the structure for a while statement. So we start with a loop header that evaluates the condition and then evaluates the body and jumps back, otherwise jumps to end. And we always start by evaluating the condition. However, for a do while statement, we will always evaluate the body and then evaluate the condition. So all we need to do to implement do while as opposed to while is to, instead of jumping to the loop header, we're jumping to the loop body. That's it. This means that we will always execute the body once and then jump back to the loop header. So we're switching over the loop kind. For a while loop, we need to check the loop header first. For a do while loop, we need to execute the body once first. And now we're getting the correct semantics for do while. So while versus do while is just, that's the entire difference between while and do while. It's quite easy to do in CodeGen. Which of course means we can't do constant folding. So because like even if the condition is false, we might, in a do while loop, it's still executed once. So don't worry about constant folding and do that later when we do like general optimizations of the generated assembly. Okay, so those are do while loops. I will write tests of grammar. So add do while loop. Now we could do for loop, but we will do that later. Let's just do instead a continue and break, which should be relatively straightforward to implement. So they are called jump statements. I'm trying to think of a nice term that can be used to unify break and continue. But let's just write two separate kinds of statements for those. So return break statement. Let's do break. Yeah, let's do both at the same time. So break, continue. So they are pretty easy. I'm missing a T here. So this is a break statement, because they don't have any kind of member. A break statement and a continue statement. Break, continue. Then, how often I need to edit this time switch? So return statement, break statement, continue statement, continue statement. I probably don't need to check the grammar for those, so break statement, it's the break keyword, followed by a semicolon, and then we're constructing a break statement, and a continue statement. It's the continue keyword, semicolon, and we're constructing a continue statement. Just realized that I forgot to do something that should. So when we pass an identifier, we need to reserve all the keywords. So break, continue. Otherwise, they would be able to be created as variable names, which would mess up the grammar a bit. Forgot to do that. Sadly, this is not done automatically because it would require some sort of reflection to get all the, which is a bit unfortunate, but well. Okay. So we should now pass those. The interesting thing is CodeGen. So what? Let's do them here. So we want to do a break statement. So essentially, what we want to do is we want to generate an unconditional jump for a break statement to the end of the loop. So we need to know what is the current end of the loop. So what we need to do is we need to simply set to the variable current loop let's just so we need to keep track of what is the end of the loop. So for return statements, then what we do, we just jump to the end of the loop. Let's just also assert that we're having one. Break statement outside of loop. And so here, what we're doing, we need to keep track to handle like nested loops properly. So let's remember what the current value is. Overwrite that, and then at the very end, what did I call it? Brief loop end. Okay, and that should be all for break. And then likewise for continue, we want to trigger the next iteration, but what that means is jump back to the header. So we also need to do the same thing for the header, loop header. Header in the statement outside of loop. And so we do the same thing here. So we need to remember the previous loop header. Then we override those like so. And then we return those. Okay, let's test this out. So let's start with 10, and let's say if n is equal to 5, then we do break. helps if we actually pass the statements at some point. So why are we only printing 10? That is a bug in the code gen somewhere. So we are apparently doing something really weird here. What? Why is my loop no longer working? So we are having, this is the function. So line 9, so line 6. Line 6 assigns. Then we're having a print. What is going on here? Let me do a regular loop. So we're loading the value, then we're printing. Okay, something isn't right here. We're immediately jumping to 10, which is this instruction. It does a comparison and then does a branch if greater back to 6, which then prints, which does a bunch of things, stores them. Okay, so that is interesting. It did work, right. So what we're doing is, so this is correct. So the first couple things store 10 into the local variable. Then we're having a jump to instruction 10. The jump in instruction 10 loads the value, compares it against 0, and if it's greater than 0, then we jump back to 6. 6 is correct, so we print it. Then in line 10, we do a push. This does a subtraction, and then does another comparison. So we should see at least one print, since we are printing. Should see at least one print, since, oh no, we're jumping to the condition. So maybe the condition isn't. What is going on here? Let me see whether this was there before. Maybe I should have written a test first. Okay, so it is something that broke with our change. So that's nice to see. Let's see what did we change. So it's probably not in here. This is the new code. So we're remembering the current loop header, the loop end, and then switch the block declarations around. Loop header. That is okay. I'm assuming this is a bug in the code that is responsible for this is a bug in Loaf somewhere, because I swapped those two around and then it stopped working. Now it works. Okay, so there is some bug in somewhere in Loaf, which is precisely why I'm doing this project. I want to like test Loaf in production, see how that goes. So I need to declare the loop header before the loop body, otherwise something breaks. Keep that in mind. I'll debug that off camera. Okay, So let's see whether break works. So if n equals 5, we want to break. Okay, so we broken when n is equal to 5. And let's see continue, which means we're having an infinite loop now. We're having an infinite loop because n keeps staying 5. So let's do the subtraction first. This now should print every number except for 5. Okay, so I would say break and continue works. Modulo whatever's going on in love. There is somewhere in the way it does something breaks. Okay. Add, break, and continue statements. And I will also add exhaustive tests of grammar. Okay, so I've got I aim for like around at most 90 minutes, so I've got a bit of time left in the stream. What's something easy that we can do? So goto is tricky because of labels. Because goto is actually the only thing in C where you sort of like, when you see goto first time, you don't know where that label is yet, right? It can be somewhere below. So this needs to be handled. Oh, I know what we should handle more gracefully. If I do that, I will get an assertion failure during CodeGen instead of a compiler error message before we generate the parse tree. Hang on 1 second, I'm getting a phone call. Okay, so we want to handle this more gracefully. Generate a proper error message for break or continue statement outside the loop. I wonder what's the best way of doing that. Let's just for now say we have inside. Also, a break is also allowed inside a switch statement, I suppose. So let's just say allow break and allow continue. Okay, and then we just set them. So when we do a break statement, actually want to do like a callback thing. So a callback that takes a break statement, turns the pointer to a break statement, gets the compiler state and the position, then return state as create the break statement on the position. So this should still compile. Okay, and then if not state.allow break, then I want to generate an error message. State dot my language server keeps crashing, it's so annoying. So the error is break statement not allowed in this scope. And then we've got the location of yeah, I can just pass in the position here. Okay. Okay. That's a bit annoying. Right, it would be nice if the position covers the entire thing. So let's do that. So we do get a begin and end of the break statement by capturing it, and then I convert that into a position. Lexeme begin, lexeme end. Is it called location? Okay, so this is a location, and then I construct it from a location. And now, right, so we got a nice error message that the break statement is not allowed in the scope. Then it underlines the entire thing. Okay, the same thing for continue. Construct the continue statement. Continue. Yeah, continue. Continue statement. It's unused. I'm fine with the copy paste there. Not too worried about that. But of course, what we need to do is actually allow them at some point. So what I want to do is I want to allow them inside a loop. That's a bit hacky, but this is something that I will, yeah. So let's do this. So when we start passing a while statement, so we want a callback that returns while statement loop kind t, which takes the compiler state, and then inside a while thing we allow break and we allow continue. And I can't make them Boolean because we have got nested loops. So we need to figure out that's annoying. Okay, so the idea was that we set allow break and allow continue to true before we enter a while statement, and then when we leave a while statement, we set them back to false. But when we have a nested loop, a while statement inside a while statement, we can't set them back to false yet, only when we enter the outer loop. So we can't have booleans, we have to use integers. And this is now a lot of work for something that we need. This can be a lot. So the proper fix would be, because we're not handling something else at the moment, we're also not handling local variable declarations. So when we're having nested scopes, a variable inside an inner scope is not accessible in the outer scope, and we're not handling that either way. And to fix that, we also need to implement scopes. So, and while we implement scopes, we can also need to keep track of the current scope anyway, and this would be a much nicer solution. So I will actually not worry about those right now. So let me revert those changes, because probably next time we implement proper scope handling, and while we do that, we can also solve that problem. So if we have a break outside, we're currently getting an assertion failure during CodeGen, but that is totally fine. Not worry about that. I'll fix that later, next time when we do that. Yeah, but I can't get anything else done in the remaining half an hour, so let's just end it here. Thanks for everyone who stopped by. It's really nice to see that our interpreter is now actually, now that we're having loops, we can use the interpreter in ways where it's possible. Next, on Thursday, I will implement proper scopes and probably things like variable initializers and do some other minor stuff. And then next week, we will start adding a real type system to C. So currently we are only having ints, and then we will add more types there. Okay. Thanks everyone. See you until then.